Alright, let's take a look at derivatives. So first thing I need you to do is cut some tabs. So right at the end of the margin, just like I just did. Title is derivative, which is just another word for slope. So derivative means slope. That's all it is, slope. Alright, so what is slope? Slope is a change in y with a change in x, others known as rise over run. That's for a line, right? So that's the slope of a line. What about if you're asked to find the slope for a curve? This is a listening check. Underline the word curve. What would that look like? So let's start off by drawing a simple curve. Let's say we were asked to find the slope of this curve. What we can do is we can use what we know about the slope of a line. So let me draw a line. It goes through 2 points, and it's a special kind of line. It's called a secant line, which simply means it crosses the curve at 2 points. A straight line that crosses the curve at 2 points. This is a listening check. Shade in secant line. Shade in secant line. And now what we can do is we can use the slope of the secant line to approximate the slope of the curve, because we know how to find the slope of a straight line. So let's figure this out in general terms so that I can now use this formula forever. So let's mark our 2 points as an x value and as a y value. So let's call this x1. If that's x1, once you plug it in to the function, you're going to get f of x1. And then this next point, let's say the distance between x1 and this next point is h, some variable. So this next point is x1 plus h, because x1 plus h is going to give you that next point. Which means when you plug it into your function, you're going to get f of x1 plus h. Once you plug in that answer in your function, whatever you get, the output you get is going to be your answer. So let's take a look at what the slope is for the secant line. It's a change in y, which is a change in y, so that's f of x plus h minus f of x1. And the change in x, the change in x is x1 plus h minus x. Let's go ahead and simplify this. So the top, nothing to change, but on the bottom, look, x1 minus x1 is 0, so all we're left with is h. So this is a very, very important formula. You need to memorize it. It's called the difference quotient. I never memorize it, I just know how to get it. So just understand how to get it and you'll be okay. So the thing to note is the further the 2 points are from one another, the less the slope of the secant line corresponds to the slope of the curve. So the further away the points are, the more your approximation is off accuracy-wise. This is a listening check. Shade in further and less the slope. However, and let me show you this with pictures. So let me draw 3 separate curves, the same curve, but what I'm going to do is I'm going to get the 2 points closer and closer to one another, and then you can see how the slope corresponds more and more to the curve. So start off with the 2 points very far away, move them closer together, and move them closer even. And you can see as the 2 points get closer and closer, the slope of the line gets closer to the slope of the curve. So the closer the 2 points get to one another, the more accurate the slope of the curve. This is a listening check. Shade in closer and more accurate the slope. Closer, more accurate the slope. In fact, there is one line, which is called the tangent line, that touches the curve at exactly 1 point. Very important. Tangent line touches the curve at exactly 1 point. Alright, so graphically it looks something like this. So there's my curve, and then it just touches at 1 point. That's the closest you're going to get. So x of 1, f of x of 1. So it touches at exactly 1 point, which shrinks h. And remember, h is the difference between the 2 points xy's, which shrinks h to an infinitely small amount. Alright, so you guessed it. Since we are shrinking h to 0, we are taking the limit as h goes to 0 of the difference quotient. So this now becomes the definition of derivative. Basically taking the limit as h gets to 0, as it gets, the 2 points get smaller and smaller and smaller, what is the slope? That's what the derivative means. It's also known as f prime of x. so f prime of x. Alright, so let's take a look at a couple of examples. Number one, find the derivative of f of x equals 2x cubed at the point x equals -1. Well, write down a few steps that you need so that you know how to do it on every single question. Number one, write down the definition of derivative. If you can't read, just listen to what I'm saying. It might be too far. Number two, find f of x1 plus h and f of x1. Number three, plug in 2 into 1. Plug 2 into 1. Number four, this is a listening check. Put a triangle around number 1. Simplify. Number five, find the limit as h approaches 0 of f prime of x. So once you find the derivative, once you find this. Number six, if looking for f prime of x at a given point, plug in points or point into 5. So if looking for f prime of x at a given point, plug point/points into into number 5. Alright, so let's take a look at this example. So number one, write down the definition of derivative, which is the limit as h goes to 0 of f x1 plus h minus f of x1 over h. Alright, find out what f of x1 plus h is and f of x. Well, f of x is 2x cubed. Alright, to explain how to do this next part, I just need to tell you one little thing. Matter of fact, I'm going to make you write it down just so that you understand it. So let's say if you were looking for f of 4, what would you do? Basically, you would plug in 4 where you see an x into your function. This is a listening check. Circle number 4. Circle number 4. Same thing for f of x1 plus h. You're going to plug in x1 plus h where you see an x. So that's what we're going to do to find out what f of x1 plus h is. So f of x1 plus h is equal to 2 times, now that's my x, that's x1 plus h now because that's my new x, cubed. So now I just need to find out what that is cubed. So I'm just going to do some work here. And again, I don't know, you probably do it differently. I'm just going to do it this way. I just multiply each one, and the diagonals always add up to simplify. So I'm going to get x squared plus 2x1h plus h squared. I forgot the h, but I think I put it in a second. And then multiply it again one more time because I want it cubed. So that's x cubed, x squared h, and I just remembered that I need the h there. And that's going to be 2x squared h, 2x h squared, x1 h squared, and x cubed. And just combining the diagonals, I'm going to get x1 cubed plus 3x1 squared h plus 3x1 h squared plus h cubed. And remember that that's what it is cubed, but I need to multiply it by 2. So I need to multiply everything there by 2. And I'm just going to simplify this when I get into the next step, just because I don't feel like writing all of that down. Alright, so you're supposed to plug in 2 into 1. So basically plug in what you just found of f of x1 and f of x1 plus h into the definition of a derivative. So the limit as h goes to 0 of that, which is this whole thing, I want to get in the house at the same time. So 2x1 cubed plus 6x1 squared h plus 6x1 h squared plus 2h cubed minus f of x, which is 2x cubed, all over h. Then it says simplify. So if you notice, 2x1 cubed minus 2x1 cubed goes away. And then we can find the limit as h goes to 0. And looking at this, I can see that 0 is going to be 0 at the bottom. You can't have that. So what I'm going to do is factor out h. Because once I factor out h, you see what I can do is I can cancel, because now it's on the top and the bottom. So now I don't have a 0 at the bottom anymore, which means I can find the limit as h goes to 0. So let's take a look at it. So find the limit as h goes to 0 of this function that's left, which is 6x1 squared plus 6x1h plus 2h squared. Anything with an h is going to go to 0 because anything multiplied by 0 is 0. So all that's left is 6x squared. So f prime of x is 6x squared. Now, the question wasn't what is slope in general, but what is the slope at the point x equals -1. So all you got to do is plug in -1 into where you see x, and you're just going to end up with 6. And that's pretty much it. So it's actually really simple. It's just a few steps. So let's take a look at a more complicated one. Let's say we said, oh, and by the way, you're going to take this page and make a tab real quick. So instead of turning it all the way down, leave a little space, turn it across and then all the way down, and then write definition there, because that's the first tab, definition of a derivative. Alright, so number 2, find the derivative of f of x of square root of x. So again, you start off with writing the definition of what a slope is, or curve. Then you need to find f of x, which is square root of x, f of x plus h, which means we're going to just plug that in wherever you see x, so square root of x plus h. And then use that to plug it into the formula, and again the steps on the left hand side of this page. So f prime of x is equal to f of x plus h, which is the square root of x plus h, minus square root of x all over h. And look at that, isn't that finding the conjugate? So in order to find the limit as x approaches 0, and I forgot to write that down, I just need to find the conjugate, which means I multiply top and bottom by the exact same thing, but I just change the sign in the middle. Alright, so let's go ahead and simplify this, see what that looks like. So that times that is just going to be the inside, so x plus h. That times that, then that times that is going to cancel, then leave in negative x. And then don't evaluate the bottom, just leave it in parentheses, because remember, usually we factor and it cancels. So let's look at the top, simplify that. X minus x is 0, leaving just h on the top. This is a listening check. Shade in limit as h goes to 0. So we have the limit as h goes to 0 of this function. And again, if you look, you've got on the top and the bottom, you've got h, which cancels out, leaving 1 over this. And then the limit as h goes to 0. So the limit as h goes to 0, you can see h goes to 0, it's going to leave 1 over, and then you've got radical x plus radical x, which is going to be 1 over 2 radical x, because, you know, an apple plus an apple is 2 apples. And that's the derivative, or that's the slope of this curve, or this function. Now let's say we said, okay, let's make it number 3. Find the derivative of this same function f of x equals square root of x at the given point 9, 3. Well, we've already done all the steps to find the general formula for it, so all we need to do is really just plug in the numbers. So the general formula was the derivative of that is 1 over 2 radical x, and we have x is equal to 9, so we're just going to plug in 9. So f prime of 9 is equal to 1 over 2 radical 9. Radical 9 is 3, 3 times 2 is 6, and 1 over 6. And that's pretty much it. So let's practice.
To wander and to roam, so put fire in these bones. By your spirit make me strong. If we like, then we own. It's time to make him known. We illuminate the dark till the day comes. We living in a dark world.